Here's problem number 11 from packet number 4 from our Calculus BC review. We say that every base, the base of a solid is a circle with radius a. So let me draw that in the xy plane. So here's x, here's y, and here's a circle with radius a. This circle with radius a, by the way, can be summarized as the equation x squared plus y squared is equal to a squared. Every plane perpendicular to the diameter is a square. So let me draw it like this. So here's a square it's coming out of the screen, but then it's pushed over to the side. And this location right here is x comma the square root of a squared minus y squared, and this location right here is x comma negative square root a squared minus y squared. Alright, which means the area of the square as a function of x is this distance, which is 2 times the square root of a squared I wrote that as y squared though, so that should be x squared minus x squared, and of course square that to get the area of the square. If that's the case, then the volume is going to be the integral from the lowest x value, which is negative a, to the highest x value, which is positive a, of this area equation dx. Now from here we can clean this up in a couple of ways. First of all, because of the symmetry about this line, we can double the volume but go from 0 to a, 4, and then this is going to be a squared minus x squared dx. So this becomes 8 times the integral from 0 to a of a squared minus x squared dx, which is going to be 8 multiplied by a squared x minus 1/3 x cubed, and this expression is going to be evaluated from 0 to a. This becomes 8 let's start it over here. This becomes 8 times a squared times a minus 1/3 a cubed minus, and then we get double zeros here. So we get 8 times a cubed minus 1/3 a cubed, which ends up being 8 times 2/3 a cubed, which ends up being 16/3 a cubed. 16/3 a cubed, which is answer D.